Hey guys, happy Friday. We are going to do some math today for chapter 5, the evolution of biodiversity. Now we're going to do a little bit more practice with calculating Shannon's index, as well as some practice doing some dimensional analysis and some calculating of percentages and all that kind of stuff. So let's get started. Our first section today is called Do the Math Measuring Species Biodiversity, and we have a lot of experience with this because we did our parking lot lab, but I just want to have a little bit of review. Okay, so let's read together. It says, environmental scientists are often interested in evaluating both species richness and species evenness, so they have come up with indices of species diversity that take both measures into account. Okay, so we're taking into account species richness and species evenness. One commonly used index is Shannon's index of diversity. To calculate this index, we must know the total number of species in a community, which is N, and for each species, the proportion of the individuals in the community, okay, that represents the species. And that is our PI. Once we have this information, we can calculate Shannon's index, which is H, by taking the product of each proportion and its natural logarithm. Remember, that's the ln button on your calculator. And then summing these products as indicated by the summation symbol. Okay, and that's that letter sigma or epsilon. I think it's epsilon. Okay, now it says the minus sign makes the index a positive number. Okay, and that higher values of H indicate higher diversity. Okay, so for proportions, we want to make sure we know that that's a part over the whole for PI. And we want to know that higher H equals higher biodiversity. All right. So let's get started on our first problem. It says, imagine a community of 100 individuals that are evenly distributed among 4 species, so that the proportion of the species all equal 0.25. We can calculate Shannon's index as follows. Okay, so we know we have 100 individuals. Remember, we always want to highlight our numbers that we're given, so that the proportion of the species all equal 0.25. Okay, so we know that we have 25% of each species. Okay, 25% of each species. So if we follow our Shannon's index up here, okay, we know that H, let me do this in pencil just in case. We know that H equals negative 0.25 times the natural log of 0.25 4 times. Okay, so we want to take the total or the sum of each species. Each species is 25% of the whole, and we want to take PI times the natural log of PI for each of these species, and then overall we're going to negative it, or take the opposite. Okay, so I'm going to use parentheses and brackets. Okay, parentheses to find each species, and then brackets to add them all up, and then take the negative. Okay, so we have there, here's one species, two species, three species, 4 species. Okay, so 1, 2, 3, 4. We total them all up, and then we take the minus sign. So let's take it a step by step. If I put this into my calculator, okay, I'm just going to calculate one of them. So I'm going to have 0.25 times the natural log of 0.25 equals negative 0.35. Okay, so I know that in each of these parentheses I have negative 0.35. So I'm going to take the negative bracket, so I have negative 0.35 plus negative 0.35 plus negative 0.35 plus negative 0.35. And I still have my overall brackets because I'm going to have to take the negative at the end. Okay? So, if then I add negative 0.35 plus negative 0.35 plus negative 0.35 plus negative 0.35, that's going to give me negative 1.4. Okay, so I have H equals negative 1.4. Okay, now I know a negative times a negative is a positive, so my final answer is 1.4. Okay, now no matter how many species you have, no matter what their proportions are, you're always going to follow these steps in order to calculate the biodiversity index. Okay, so the next two problems, okay, we have a community with 4 species. Actually, I forgot to. Okay, so we have 4 species. Okay, we have 94 individuals. One species has 94 individuals, and the other 3 species are represented by 2 individuals. Okay, so you're going to calculate the Shannon's index of that, and you're going to put it in your whisk form. And the last one, we have a third community of 100 individuals. Okay, and those individuals are distributed evenly among all species, but there are only 2 species, not 4. Okay, so this one's going to be 50% each. Okay, so the work down here is actually going to be a little bit shorter. Okay, so this goes in your whisk form once you solve it. Okay, make sure you show your work here. This is going to go in your whisk form. Make sure you show your work. Alright, now let's do our next section called Measuring Your Impact, the True Cost of a Green Lawn. Okay, so it says one area of potential biodiversity improvement that many people overlook is their own lawn. Mowing a lawn and applying herbicides and fertilizer typically reduces plant diversity to only a few species of grasses. In contrast, unmowed fields can contain dozens of plant species, including many species of wildflowers that are not only aesthetically pleasing but also promote a high diversity of animal species. Okay? So, our green lawns have low biodiversity. Natural areas that are allowed to grow as they please have high biodiversity. Okay, so let's look at the numbers and let's look at the cost, so we can kind of determine some economic benefits of leaving our lawns, okay, the way they were naturally. Okay, so first question, part A says, given that approximately 85 million Americans have a lawn and that the average lawn size is 0.08 hectares, how much total land area is composed of lawns in the United States? So we want to know how much area is lawns. Okay, so let's do that calculation. We know that we have 85 million people and we have 0.08 hectares per person. Okay, so I'm going to start with 85 million people Okay, and I know that I want hectares to be on the top, so I'm going to have 0.08 hectares, because that's what I want my final answer to be, because that's what's going to answer the question. And then I know that I'm going to have per person, so people cancel out. I'm left with hectares, which is absolutely perfect, and now I just need to do the math. Okay, so this is one that's absolutely possible to do without a calculator, and so I'm going to call this 85 times 0.08. Okay, now line this up a little bit more. Okay, so 85 times 0.08. Now if I'm going to do this in the long multiplication way, 8 times 5 is 40, 8 times 8 is 64, plus 4 is 68. Now, if this was just 85 times 8, I know that I'd have 680, but since it's 0.08, I need to move the decimal places 1, 2 places over in order to account. So 1, 2. Okay, so I have 6.8. And I know that I have million left over from here, and I have hectares. So our final answer is 6.8 million hectares of lawn. Okay? And that's going to be my final answer. Okay, so that's quite a lot of land that's going to be green lawns. Alright, so let's see what's next. It says if every landowner sets aside 10% of his or her lawn and they let it grow into an area of natural wildflowers, how many hectares of this higher biodiversity land would be added? Okay. Alright, so this is a question for your WSQ form. We want to make sure that we have 10%. We want to know how many hectares would be added. Okay? How many hectares of high biodiversity land would be added? Alright, and that's going to be on your WSQ form. Don't forget the units, guys. Don't forget the units. Alright, now, next, part C says, given that landowners spend a total of $40 billion on professional lawn care services each year, what would be the annual savings on lawn care services if 10% of all lawns were set aside to grow natural wildflowers? Okay, so we have $40 billion. It's one of our numbers. We have 10% set aside, and our question is asking what would be the annual savings? Okay, so we know that our final answer we want to be in dollars. Okay, so we're going to start with our 40 billion. And we want to multiply it by 10%. Now an easy way to multiply by 10% is to just move the decimal place over 1. Okay? So that's going to give us $4 billion saved. Okay? So we're just going to move our decimal place over, and we're going to save $4 billion on lawn care by just saving 10%. Okay? Alright, next, part D. It says approximately 2.2 billion liters of gasoline are used annually for lawnmowers. If gas costs 80 cents per liter, how many total dollars will be saved in the United States each year if lawn owners stopped mowing 10% of their lawns? So here we're at saving 10% again. We know that gas costs 80 cents per liter. We know we use 2.2 billion liters every year. That's what annually means. So we want to know how many total dollars could be saved. Okay, so again, we're looking at savings. Alright, now I want to start with 2.2 billion liters. Okay, in order to cancel out liters, I'm going to use my gasoline conversion factor, so $0.80 per 1 liter. Okay, that cancels out our liters. Now, an easy way to do dimensional analysis with percents, we know that we are going to stop mowing 10%. So 10 over 100 is the same as saying 10%. Now, we also can cross off our zeros. Okay, and we crossed off our units. Percentages don't really have units. Okay, so I know I want to do 2.2 times 0.8. Okay, and that's going to give me 16, 17, and I have 2 decimal places that I need to go over. Okay, so I'm going to have 1.76, and then I know, because 2.2 times 0.8, and then I still have this 10 that I need to divide, so I'm going to take 1.76 divided by 10, and remember, when we're dividing by 10, we're just going to move our decimal place over. So it's going to move over here, so I have 0.176 billion. Now, what comes before billion? That's going to be million. Okay, so if I have moving the decimal place over and I don't have enough for 1 whole billion, this is going to be in the millions. Okay, so I'm going to have $176 million saved. Okay. Alright, and the last question is pretty conceptual. What do these data suggest about the economics of preserving biodiversity? Okay, so remember, economics is all about the money. This question is your last question on your WISC form. Do not forget to ask a question. Okay, if you are confused, if you'd like more practice, kind of what you're looking for after this lesson. Alright, and have a fantastic weekend. See you Monday.